Hello, and first of all, let me welcome you to my video. This video covers my lighting scheme project. Allow me to give you a broad overview of what will be covered in the following video. Overview of the combined lighting scheme, the lighting scheme selector, the accordion lighting scheme in detail, findings and recommendations from my project. Firstly, let's take a look at a simplified block diagram to familiarise ourselves with the design, working from top left to bottom right. Starting at the user interface, this is a single push to make switch that will be connected to the up and the main counter, allowing it to count up as required. The main counter will be connected to both the user display to indicate the scheme selected and to the main demux block, which we'll discuss further later on. Moving back left, we have lighting scheme from lighting scheme 0 to lighting scheme 7, connected to the main demux block through a bus of 64 wires. In the center, we have the main demux block itself, consisting of 8 demux, allowing the select lines from the main counter to select which one of the 8 lighting schemes appears on the 8-wire bus output of the main demux block. On the right hand side, we have the 8 LEDs, which are connected to the 8 output wires of the main demux and display the selected lighting scheme. Now to compare our actual lighting scheme to our simplified block diagram. In the top right hand corner, we have our user interface with our single push to make switch and our display. Below that, we have a centralized bank of clocks, which would now have replaced all the clocks within the lighting system. Below that, we have our centralized logic, which have replaced all the logics within the lighting schemes with these 2 logics. As previously discussed, we have our main counter. In the center, we have our 8 lighting schemes, and to the left hand side, we have our main demux block, which we'll now discuss further. The main demux block, it consists of 8 single demux acting together to form what we are referring to as the main demux block. It's important to note that each demux is connected to a single LED. We'll begin by looking at a single demux to understand how they work together. The inputs of the demux are labelled X0 to X7. So for example, the output of our first lighting scheme that traditionally would have gone straight to the first LED now goes to X0. The second output of the first scheme goes to X0 on the second demux, and so on. The second lighting scheme will go to X1 on each of the demux blocks. The third lighting scheme will go to X2 on each demux, and so on. Moving down along the demux, we have our inputs labelled A, B and C. These are connected to our main counter from our user interface, which we spoke about earlier. The inputs allow us to select which input from X0 to X7 is transferred across to our Y output. For instance, if we have 0, 0, 0 placed on ABC, then X0 is transferred to Y. If we were to have 1, 1, 1 placed on our binary inputs, then X7 would be transferred across to Y. One more example, if we had 0, 0, 1, then we would have X1 transferred across to our Y. Lastly, the E of the IC, which is the chip enable, which in this case is an active low, is connected to a logic 0 in order to turn the IC on. And as we can see, the output of this main demux block is just 8 single wires, which we have connected to 8 LEDs. We'll now look at our lighting scheme in detail. starting on the left and working our way to the right. We'll begin by looking at the demux. It must be noted that the output of the demux are active low, meaning that they are logic 0 when active and logic 1 when not active. This means every time the clock goes high, you get a logic 1 on Q0 because the IC is turning off. And when the clock goes low, the chip is turned on. Because the select lines are set to 0, 0, Q0 is activated, which means it is a logic 0. This provides our next component, the counter, with a clock on up and a logic 1 on the down, which we need in order to count up. Next, moving to the counter, we are using 3 outputs on the counter, as we need to count from 0 to 7 in decimal, or 000 to 111 in binary. Noting that the Q3 is connected to the master reset on the counter. On the count of 8, the counter will be reset by the master reset. You do not actually see this as it happens instantaneously. This provides us with the binary count from 000 to 111 we need for the next component, which is another slightly larger demux. Before moving on, other connections of note. The preload is an active low. We do not want to activate this, so it is connected to a logic 1. Now moving to the demux. As the demux receives a binary count from the counter, it activates the corresponding output. For example, upon receiving the binary count 111, Y7 is active. Upon receiving the binary count 001, Y1 is active. Upon receiving the binary count 000, Y0 is active. This results in a walking 1 effect on the output of the demux. Other connections of note before moving on. E1 and E2 are active low, so are connected to a logic 0. E3 is an active high, so it's connected to a logic 1. These are in order to turn the IC on. Lastly, but equally the most complicated part of the scheme, is the JK flip-flops. As we've already mentioned, we have a walking 1 on the output of the demux. And because the first output of the counter goes to J, which will set the JK flip-flop, meaning that Q will be latched on logic 1. And because the output of the JK flip-flop is going to our 2 outermost demux in our main demux block, it means what we are actually doing is turning on the 2 outermost LEDs. This process is continued because the next output is connected to the next JK flip-flop that is connected to the next demux in our main block, 1 step inwards. This process repeats until all LEDs are then lit. Then the Y4 output, which again is connected to a K, the clear of our last JK flip-flop, meaning that the flip-flop resets, meaning that Q0 is now latched on logic 0. And because that flip-flop is connected to the 2 centermost demux of our main demux block, the LEDs begin to turn off, going outwards. And as from our inserted video, you should now be able to see the sequence of what we have just described. The lights starting on the outermost and working its way inwards, then turning off from the center and working its way back outwards. Finally, a few short words on my findings and recommendations for the project. Independent learning. Personally, I enjoyed the independent learning aspect of the project, as this suited my style of learning, allowing me ample time to assimilate new concepts and information. Initial compilation on A0. While my lighting schemes were produced on separate pages and copied into the larger A0 at the end, this approach did induce its own problems. But what this approach did have as an advantage was allowing a modular design and confirmation that each scheme actually worked independently prior to the A0 compilation. ROM file path. This issue presented itself more than once in the completion of this project. Possibly with more time, a sustainable solution could be found, but for now, every time the lighting scheme is moved location, you must manually update the file path. Centralized clocks and logics. I feel this element, in conjunction with the wire labeling system, allowed for a far superior and more aesthetically pleasing project overall.